Hello valued viewers, I hope you're all doing very well. It's been a couple of weeks now since the Mig-29 came out in high fidelity, and you guys have asked me to do a video showing how to set up and use the SPO-15LM radar warning receiver and the countermeasures. So let's start here. Armament screen. In terms of chaff and flare, we can have 60 total. We can have 30 chaff, 30 flare, or 60 and 0, or 60 and 0. So let's go with 30 and 30. Now, in terms of setup, it's best to use the DCS system because that's where we get most functionality. So we have our Mig-29 there. He's known as Aerial 1. We go Edit. We go DCS Manager. We go File. We go New. Type of aircraft, obviously, is going to be the Mig-29, and let's just call it Cap Mig-29 for today, and OK. We don't want navigation. Instead, we want weapon. We don't want target, we want CMDS. First is the RWR program. At the time of making this video, there are two options, stock and automatic. Stock Warsaw Pack means that it will be the realistic detection program of the jet at the time of the fall of the Soviet Union. This is the program it would have had. However, that's not necessarily useful in DCS because we have aircraft that are more modern than that, and we'll obviously have more modern planes coming in like Eurofighters and whatnot. So you can also have automatic, which is the default. All that means is that when we enter the mission, the RWR program will be set to include any relevant types of aircraft, SAMs, ships, whatever, that are in that mission. It means we can play a 1980s plane in a 2000s mission. Chaff and flares, we set the program for these up here, pretty much the same as we set for any of the jets. It's salvos and bursts. So a salvo is a quantity of bursts with a set time between each burst. A burst is a release of chaff and or flare, followed by an interval, and then the next burst, and so on. So if I start with salvo, let's just pick a number 4. I want 4 bursts to happen. In between each burst, I want, 5 seconds. In terms of the burst, which countermeasures actually get sent out, I could have burst 1 and 2, both set to 1. With, let's say, 1 second in between. What that would do is, if I pressed the flare dispense button, 1 flare would come out, 1 chaff would come out with a second in between. Then 5 seconds would go by, and the next burst would go again, 1 chaff and 1 flare. If I wanted an alternating asymmetry between chaff and flare, I could have, for instance, 2 and 1. This would mean that the first burst would be 2 flares and 1 chaff. Then 5-second wait. The next burst would come along, and this time it will be 2 chaff and 1 flare. 5 seconds, back to 2 flare, 1 chaff, and so on until the salvo ends. Air, obviously, is what we're interested in. And we can go on in that vein. Let's just use 2 and 2. That means the burst is going to be 2 flares and 2 chaff, wait 5 seconds, 2 flares and 2 chaff 4 times. Next, we need to save. And we need to apply it. So load to group, choose the group, it's Aerial 11 there, add, OK. Now before we go into the sim, I'm going to go into my plane and just check it actually worked. So DTC, you can see that Cap Mig-29 is loaded. Out of interest, if we went to additional properties here, you can also set the RWR program here, stock or automatic, but I believe that if you set it there and then something else is set in the DTC, then the DTC will overwrite that, so just be awares. And to deploy, simply press flare dispense button, depress, and if I press that, we're going to trigger the program. 2 flare, 2 chaff, wait 5 seconds. 2 flare, 2 chaff. 5 seconds. And 1 more, hopefully. That's it. Right, let's look at RWR. So, in the cockpit, let's lock ourselves down here. There are 2 panels that we're interested in. The SPO panel there and the actual RWR panel there. First, the SPO panel. We can change a rheostat here for the audio volume of the system. Also down here, we can turn the system off. And we can turn it back on. When it's on, it obviously initializes itself, and we can tell it's on because the nose of the aircraft there has a slight illumination in that light there. Finally, we have this guy, allow search switch. What this means is if we have it on, it means the RWR will show search radars and track and guidance radars. If we have it turned off, it will have track and guidance radars but not search radars. In terms of the panel itself, it's pretty much a standardized 1980s Soviet RWR. We've got this in Flaming Cliffs aircraft, but it's a much more simple version in there. Here it's much more complex and highly modelled, which means it's going to take a lot more mastering. Obviously, we are here, we're pointing that way, and we're looking down on our aircraft. The system has 10 channels. Each channel listens on the electromagnetic spectrum and compares received signals to the program that's been installed. Each channel is configured around the aircraft so they cover a certain azimuth. This guy, 10 degrees left of nose, 30 degrees left of nose, roughly 90, and roughly rear and left, and the equivalent on the right side. In terms of elevation, they cover a pretty much standard 30 degrees up and 30 degrees down. So remember, there are blind spots kind of directly below and directly above. Each of those 10 channels can detect and warn us of multiple detection intercepts known as events. Those events can be various types of radars as covered in the installed program, and multiple channels can detect events at the same time. So this one could be detecting an F-16, that one could be detecting a Tomcat, and that one could be detecting a Phantom, all at the same time, and warning us about it by flashing green when it intercepts the signal and giving us an audio tone. But the way the system works is it will only give you more information about a single event. That is called the main or the primary event. The main event will be shown in one of the yellow lights around the outside here. So we may have multiple greens going off, but only one yellow. Caveat to that, if an aircraft is equidistant between, let's say, the 30 and the 50 degree azimuth, it's likely that it will show in both channels, that channel there and that channel there, and even it may show both main events there and there, even though it's just a single aircraft or ground radar or whatever. And that's probably a good time to say that this is an extremely simple system, much inferior to equivalent NATO systems. The MiGs and Sukhois of the 1980s were excellent planes mechanically, but in terms of avionics and especially electronics, they were very poor, probably equivalent with 1960s NATO. You should also note at this point, this is strictly an analog system. It is not a digital system. With regards to the main or primary event, let's say it's an F-14 at 30 degrees on the port side, we can also get the signal strength showing by this set of bars here. The stronger the signal, the more of these bars from the right hand side will show. A stronger signal means that the transmitter, aircraft or SAM or whatever is closer to you, but caveat, it's in proportion to the strength of that radar. So for instance, an F-14 showing, let's say, 3 bars, and an F-4 Phantom showing 3 bars, the F-14 will be much further away because it's got a much more powerful radar. But this system doesn't understand that. It just listens to decibels, as they're called, of event loudness. In terms of elevation, we know if the radar is below us because the H hemisphere will show, and above us because the B hemisphere will show. Note, certain parameters have to be met for the elevation to be shown. Sometimes it simply won't know. So far, we've looked at search radars, which is most of what is going to be out there. If we're locked, then this red background will show red and we'll get a warning tone. At that point, we know that we're locked. However, we can't differentiate, for reasons I don't understand, between a lock and a missile being fired. So the best thing is, if it's showing red and we're locked, assume that we're going to be fired at. That may change later on, I'm not sure. So we now know where search radars are illuminating us from. We know if they're tracking us, but what we don't yet know is what those types of radars are. And that's these 6 guys along the bottom. Same type of method. We can have any number of green showing. And that means that the system is classifying the events, the green lights that it's showing along here, into one of those 6 categories as defined by the program that we installed in the mission editor. In terms of what those categories mean, it depends on the program that you've installed, and we'll obviously go through that when we run our test. Although we can have multiple green classifications, we can only have one yellow classification, and it's the same thing. That is the primary event. So the Tomcat at 30 is our primary event. Let's say he's a Cyrillic N, then only that yellow light will show. And that's pretty much it, to be honest. We've obviously got a brightness knob that you can do there, and you've got a built-in test which you can run there. In terms of today's mission, we're a Mig-29. We're paused here, and I've set the mission up so I can spawn in any type of NATO fighter or SAM whenever I want. If you want this mission to practice, just message me in the Discord and I'll send it to you. We're going to go to Communications menu, we're going to go to Other, we're going to go to F4 Spawn, and let's see what comes up. So he's spawned in, and we can check. There he is, he's coming towards us. Alright, we are picking up a search event. You can see it's pulsing quite quickly, and that's just simply due to how his radar works. It is passing our aircraft once every second, or whatever that is. The strength is 1, 2, 3.5 bars. Remember, that's proportional to the strength of his radar. Finally, the type classification. We've got a solid C here, and obviously he's the main event, so he's showing on that 50-degree lobe there, that channel there, and he's the main event showing there. Now, what does C mean? At this point, we need to go right shift and kilo, kneeboard. We're going to go right here, and it's going to take us through to our program. So we've got Cyrillic N, we've got X here, 3, H, and F, as set by our program. As I said, it's a pretty simple system. So if I went to C as an example, it is there. All we know is that that type of emitter is either an F-14B, an F4, an F-104, blah, 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 blah. It's one of those, but we don't know exactly which one it is, and that's because the system is simply not that good. It's going to give us a general idea, and therefore it's going to take a lot of pilot practice to understand how to use it and cross-reference it. In terms of remarks here, that's pretty important. It's not the type of radar event. Instead, it's the way that event is transmitting. It could be a continuous wave radar. It could be a continuous wave illuminator. It could be a quasi or quasi-continuous wave, i.e. a high pulse repetition frequency. It could be that one there, PZHNF-OCCL. It could be a launch, although that's only relevant to a type of sound we don't have yet. Or it could be a jitter, which is an unstable pulse repetition frequency. So that's another way we can narrow down what's illuminating us. So we can unpause and pretty much wait until the next thing happens. I can scroll that forward. We can see I've only given him a gun. So he's only going to track me at about, I don't know, 5 or 6 miles. Almost full bars now. 4 miles. And he's finally locked me. Pause. I didn't see when we could see it, but at some point we could determine his altitude in relation to us. It says it is above us. Let's see if that's right. Yes, he is a couple of thousand feet above us, so it's done its job right. We know that he's tracking us now, so we're in danger, and he could be firing a missile at us, although he's not, obviously. Now watch what happens as he gets closer. Watch how he disturbs the other receiving lobes or channels. So you can actually tell as these lobes started illuminating, these channels came through, that it was moving from left to right around us like that. Now at some point it's probably going to turn around and go for a rear hemisphere, set a rear lobe off. Let's have a look. Why are there less lobes on the rear, by the way? Well, it's because situational awareness wise we're more interested in the front hemisphere. And you can see now he's below us, he's tracking us, and he's in that lobe there. Unpause. That's pretty much all I can show for that guy there. We'll reset. Let's try a Tomcat, which is going to give us something a bit different because it's a different type of radar. So, let's have an F-14 spawn in. Let him populate. I think it's from the 12. No, he's from the 10 o'clock. So, 30 degree, that's our main event, and that's him there. Now look at this. Although we started the same distance away, he's 5 bars already, and that's because it's a much more powerful radar. Also note how the frequency that he's actually pinging us is lower, and that's just the way that his radar is scanning us. It's just working different to the F4. Now the most interesting thing is he's showing as an X-ray here, and that's obviously the main event, so let's go and have a look at X-ray. It is a Hawk surface-to-air missile system. Well, something's not right there, because obviously it's an F-14, it's not a Hawk SAM. So at this point I had to do a little bit of digging. The natural thing to think is, oh, the system's bugged, it's not meant to work like this, but I think it actually is. If we look in this excerpt from the manual here, it explains that there are a huge amount of limitations on this system, and that goes back to what I was saying at the beginning. It's a very simple analog system. I mean, to literally change some of the things it can receive, rather than reprogramming it like a NATO system, a guy had to pull this panel out and resolder different wires together. That's how simple it is. And a couple of the limitations that it has piqued my interest. Let me read this one. The continuous wave detection circuit can falsely detect high pulse repetition frequency signals at lower power continuous wave signals. Due to a higher sensitivity of the continuous wave circuit, HPRF emitters will usually be detected as type X long before they are detected as pulsed radars. Obviously, we have a pulse Doppler radar in the F-14. The difference could be anywhere between 6 and 14 decibels, that's the loudness of the EM signal, depending on the emitter frequency. To denote the identification as ambiguous, low power type X detections are indicated by a flashing X, which is what we've got here, by the way, as opposed to a solid X. Additionally, when a HPRF type is positively identified, the continuous wave detection circuit is shut down, preventing detection of actual continuous wave threats. This needs to be taken into account when operating in an environment with both 4th-gen fighters, like Tomcat, and Hawk battery. So what he's saying is, at this point, is the system has mistaken the F-14 at long range or low decibel level for a Hawk system. So if a real Hawk system were to pop up now, which I could do right now, it would actually bleed over that and we wouldn't detect the Hawk system. Again, it's meant to do that. It's showing the limitations of 1980s Soviet electronics. Just before we move on, there's another really important one. When the onboard fire control radar is radiating, the forward hemispheres of the RWR are completely disabled. This is necessary because the device is not capable of effectively filtering out HPRF signals from the Mig-29's own fire control radar. So it's going to take a lot more user interpretation to figure this system out and get the most out of it, which is again what today is all about. I'm going to unpause now and we'll see what happens. So reminder, F-14 is a long way away and we're mistakenly detecting his radar as a flashing X, i.e. a Hawk, or something that is obscuring a Hawk signal. Otherwise, we don't know what it is yet. So all I can really do is speed up time now until it gets closer and we can detect his pulse radar better. There we go, here we go. So it's still, we've got that bleed through there, but now we've got more bars, we can detect what he actually is, and he is a Cyrillic N. Cyrillic N is, oh surprise, surprise, an F-14B. We've got continuous wave illuminator and a quasi-continuous wave. So that's it, that's as good as we're going to get. It won't tell you it's an F-14, it will tell you it's one of those there as set in the program. Again, old Soviet electronics. Probably not much will happen that's different now until he locks us, so let's see with that. And I've probably got nothing new to show you here, but we'll do it anyway. And he's tracking us, and the rest is going to be as we were before. Let us do it again. Let's do an F-15 this time, but this time he's going to have a missile. Now, the F-15 has a powerful pulse Doppler radar. Probably the same thing is going to happen. There he is. He's the main event. He's the only event, 10 degrees right. We've not got a classification at all yet, so we're going to wait for more information to come through before we can classify. There's a classification. Again, it's bleed over on the X, which is flashing. It's very low. Interestingly, it's much less powerful than the AWG-9 on the F-14. Wasn't expecting that, but okay. In fact, yes, one thing, multiple events at the same time. So let's stick an F-4 Phantom in at the same time. Let's see which it's going to classify as the main threat. So we've now got an F-4 Phantom at 50, and we've got the F-15 at 10. Now it's made the decision that although the F-14 is pulsing us more often, oh no, look at that. It's now chosen the F-4 as, no, it's switched again. Pause. It's trying to decide in its own tiny little mind which is the primary event. Is it the F-15 or is it the F-4? And it's getting a little bit confused and it can't make its mind up whether it's F-15 or F-4. Let's give it a bit more time. In terms of what it's telling us in terms of classification, the F-4 is a C. You can see the C highlighted down there, but it's not the main event. The flashing X, well, it's just lost the F-15 now. There's the flashing X, and now this is the main event. It's going to keep swapping between them. Again, I think it's meant to do that. It's simulating very old analog tech. So again, to actually use this to figure out the battle space around you, you've got to be really smart to know what's going on. I mean, with our experience today, we know that there's an F-4 out there. We know it's not the primary threat. We know the primary threat is something else, or probably is something else, and we know it's a long-range pulse Doppler radar. And that's all we know at the moment. And it's going to change. Pause. What's happened? Okay, we've got more information now. Now that the F-15 is locking us and probably gone to continuous wave, I will check. We don't know his altitude yet or his elevation. We do know he's locking us and maybe firing at us. So let's go and find out what F means. Solid F, not flashing, and main event. And he'll probably stay the main event. F is what the Soviets called an F-series radar, covering the F-14B, the F-15C, not the F-16 and F-18, but added in because we've got automatic mode on, the F-14, the F-15, and the F-16 in different types of transmission. So he's one of those guys there. And that's pretty much it. I guess we let him fire at us next. You can still see that we're watching, maintaining view on the F4, but otherwise, no extra information is going to come. Let's let him fire at us. He's now fired at us. From my memory, I thought the old Mig-29 radar used to flash when launched on, but this one doesn't. I don't know if that's going to change or not. We'll have to see. But we've got more information now. We know that he's above us. Otherwise, we've got nothing other than the fact that we're probably about to die. Signal strength, we know is getting closer. If you learnt the power of all the radars, you could then have a little chart to tell you how many bars refers to how many miles. But, you know, who actually does that, right? Boom! Indeed. That's all we're going to get out of that. Let's quickly watch the SAM. Sorry that it's taken so long, viewers, but this is, you know, it's not a simple thing. It's not meant to be a simple thing. It's not modeled to be a simple thing. Finally, let's just whack on the Hawk. Let that spool up. You see, it's at 40 degrees. I put it there on purpose, and it's showing as a main event on 30 and 50. So we know, well, actually we don't know if it's 2 Hawk SAMs or if it's 1 at 40 degrees. Again, super simple system. We know it's an X this time. It is actually going to be a Hawk site. And let's see if he's going to fire at us. He may or may not. Yes, he will. He's locking at us. He's now a solid X. We now know it's definitely a Hawk site that's shooting at us because it's X in it's in that category. It's a strong radar signal, so we know it's near us, which it is, and obviously we're going to get hit and blown up again. And that is the radar warning receiver in the Mig-29A. At the moment, it's difficult to use. To use that and actually understand what's around you, you've got to learn all those tables, the programs, and the intricacies of them and what they could be trying to tell you. That's all I've got to show. I hope that was useful, and bye-bye.